Hi everyone, this video is gonna be an introductory video to SHAP analysis. So what is this SHAP? SHAP, it basically stands for Shapley Additive Explanation. It's a technique that is basically used to explain the output of any machine learning model according to the prediction of its input features. So you can think of SHAP as an explainability microscope for black box models like random forest, XGBoost, LSTM. So the thing is that I think some of you are still confused. The thing is that why we need SHAP or where did it come from? So basically, when we are working with machine learning models, they're doing their predictions, right? You're using random forest, you're using XGBoost, LSTM, or whatever model you have. But the problem is there is this lack of transparency. That is, when you are working with machine learning model, people are concerned like how the model is making the decision. So that is the thing that we call the black box nature of machine learning models. So in order to address that challenge, in order to understand the transparency that how a machine learning model is doing its forecasting or how it's doing its prediction, we need to understand this SHAP because it helps us. So the next point is, why do we need it? So it's like, imagine that you're building a predictive model for like drought prediction or disease or stock prices, but no one understands how your model is making decisions. That's where the SHAP comes in. So it tells you which features are contributing most, making a specific decision for your model. It does for each individual prediction, not just globally. So you can say that this area is predicted as drought prone because of low NDVI and high land surface temperature that drove the decision making for the models. So this is an example I gave from the perspective of who are working in the environmental engineering or geography or relevant sectors. So like you're developing a drought prone model and your model like predicted that it says that in these areas there is low NDVI and there is high land surface temperature, and so they're making this decision, but it is still vague to you, right? Like how your machine learning model made this decision. We call this like lack of transparency as the black box nature of ML models. So for that we need this SHAP. It's going to explain like which features, which input features or which input variables are playing crucial roles in making this decision. And it's different from like feature importance. It just tells you which features are important in your model, but like in decision making, which model is driving in the positive direction or which model is driving in the negative direction. That's what the SHAP helps us to understand. So how does it work? So in simpler terms, no, there is nothing like complex here. So it just came from game theory in economics. Like specifically, like what they do is they're borrowing this game theory. So specifically, the Shapley values or the values that you get from the SHAP, they're used to split the payoffs fairly among the players. So, for example, you can think of the input features that you're giving, say, NDVI, LSD, precipitation, soil moisture content, or whatever you have. These are the players. And the final prediction or the total payout, these are the SHAP values, and how much each feature contributed to that specific prediction. So think how much did NDVI alone add to the final feature prediction. So it calculates the average marginal contribution of each feature across all possible feature combinations. So this is a practical example. I used a Google Colab to generate a dummy SHAP analysis for a drought prediction model. So it shows, you can see that it shows how each feature like NDVI LSD impacts the model's prediction for each sample, all in one dazzling rainbow swarm. So in the x-axis, you can see that it measures how much each feature pushes the prediction from the base value, that is the average model prediction. So the positive SHAP values, it means that you are making a prediction for VHI, that is the vegetation health index, So for the VHI, the positive values are means that the VHI prediction is going up or going forward, and the negative values means the prediction is going backward. They're having negative impact on your prediction model. And in the y-axis, you can see all the input features or input variables that you fed into the model, and these are basically ordered in terms of their importance. It looks like a waterfall, right, or a tree. So at the highest, like at the highest or at the peak zone, is the most important input feature that is playing the most crucial role in making the decision making. Now let's talk about these colors. You can see that there is red, blue, and there is something that is in between them. So the blue, these are the low feature values, and the reds are the high feature values. So it basically tells us like how much a feature matters and what direction the effects are going. So for our prediction, we can see that high NDVI, that is the red, increases the VHIs as these are on the right. And the low NDVIs, if the NDVIs values are low or less, these are going to decrease the model prediction or decrease the VHI values. So that's exactly how you expect, right? The greener areas are supposed to have much more better vegetation in terms of greeneries, right? So these are supposed to be less prone to drown. So if we talk about precipitation, which is the second most important factor in our model, we can see that the high precipitation are increasing the VHI, and when the precipitations are like they're having a negative impact because they're decreasing. So it's like more rain, more green, and healthier land, so higher vegetation. So similarly, it goes for the land surface temperature and NDWI. So this is a basic explanation for those who are working with SHAP and machine learning models. So I hope that this video helps you to understand like how SHAPs are working, and you can search on internet like if the explanation I gave you don't like or it doesn't suit your interest or your field of research, but this is just a basic explanation that's going to help you understand how it's working. Thanks.